dear Dakashers, today we're gonna discuss about the Liskov Substitution Principle, where the statement goes like the objects of a superclass they should be replaceable with objects of its subtypes without altering the program's correctness. Now this definition it seems a little bit scientific. Let me break it down for you. It simply means that if you have a class that is being used in a function, then if we replace that class with any of its derived classes, we know that derived classes will inherit the functions from the parent class. Then definitely they can use those functions. So if we replace that with any of the derived classes, then that function, it, it should not change its behavior. It should work seamlessly with with those classes as well. So how will it work? It will work if you design your classes properly. Now let me show you a wrong example first, and then we'll give you a good idea of how LSP should work. We have a shape class, and we have a rectangle class which is inheriting from the shape class. We have a calculate area function which is relatively common for all of the shapes. All of the shapes have areas, right? But rectangle has some special things. It has length and width of its own. We have some certain getter and setter functions. We have a calculate area which is customized for this rectangle class. After that, now till here LSP is definitely fine. It will work just fine. Problems will arise when you start taking the mathematical definitions very seriously and wrongly implementing it in inheritance in code. What I mean by that is, we all know that rectangle square is a special kind of rectangle where both of the sides are equal, then it will become a square, right? So why not just create inherited from the rectangle itself, and just make those sides equal. Take one parameter and just set both of the length and breadth equal to the side. It will work just fine, because you see you have a shape pointer pointing to a rectangle object, and we have calculate area for a square. Now this will give us the right answer, which is 25, 12. Problem arises when you can also set the width of this square object using the function which is already here in the rectangle. It is inheriting, right? So the thing is, when you'll do this, it will break the implementation of the square. Now both sides are not equal, and you are calculating the area which is definitely kind of undefined behavior, right, for the square. Now here your implementation is breaking. The problem is that your inheritance, the design of your inheritance, it is not at all good. It is not at all up to the standards. It is clearly breaking the LSP, because you cannot just replace the rectangle object with a square and expect it to be the same behavior. So what can be done here? Well, there is one thing we can do. We can take this shape class. We can just take this shape class and declare it as abstract. Okay, just do a pure virtual function here, and then the rectangle is inheriting as usual, but the square should also inherit from the shape. Now the square is definitely a special kind of rectangle, but it cannot inherit these functions, right? Even if you can inherit get length and get width, it might work, but this is just not good for this square. So that is why it has to inherit from the shape class. Now this is a kind of good inheritance, where the implementation will not break. Now we will not need this function. Now you can see your implementation will work just fine. We have just a rectangle and we have a square. The areas are being calculated just fine. So in LSP you can see that we have three things which are the benefits here. We have increased code reliability, where you can trust that subclasses will behave as expected, reducing the risk of bugs. We have improved code maintainability, where the code that relies on superclasses is more adaptable to changes in subclasses. We have enhanced code reusability, where you can rewrite, where you can write generic code that works with various subclasses without worrying about unexpected behavior. So this is it from my side. Thank you.
Bear with me, I'm kinda worried for the both of us.